my lab report for Lab 1 about charged tapes. In this lab, we use household items to conduct observations regarding charge on sticky tape. The purpose of this lab is to do an experiment to determine approximately how much excess charge is on one piece of charged clear tape. Some fundamental principles used are gravitational force, and the force due to gravity is given by Fg equals g times m1 times m2 divided by the distance between them squared. And another fundamental principle used is Coulomb's law, which is the force given between two charged particles, which is Fe is equal to 1 over 4 pi epsilon naught, which is a constant, times charge of Q1 times the charge of Q2 divided by r squared, which is the distance between them, times r hat, which is the unit vector of r. For the overview of the results, when using the point charge model, I found the charge on the tape to be 7.07 times 10 to the negative 8 coulombs, and when using the line charge model, I found the charge on the tape to be 1.46 times 10 to the negative 8 coulombs. So for the observations of the lab, the length of the tape was given as 8 inches or 0.2032 meters. The mass of the tape was calculated to be 0.002032 kilograms, and the distance between the two tapes when the top tape began to float was 0.015 meters. The force of gravity on the top tape was calculated by using Fg equals negative mg times y hat, where y is the position vector, and we get that to be negative 0.002 newtons. To find the charge of the U tape, we used the fact that the floating tape is in equilibrium, so the net force on the tape is 0. That means the electrical force due to the charged piece of the tape and the force of gravity equal each other. So working backwards and setting the electric force equal to the force of gravity, we can solve for the charge of the tape, and we get 7.07 times 10 to the negative 8 coulombs. For the glow script code for the point charge model, we first define our constants and then our objects, and the blue sphere is the bottom piece of tape and the red sphere is the top piece of tape. We then calculate the gravitational force, we calculate the charge, and then calculate the electrical field. And then we display our results, and it's because the two arrows coming from the red sphere are both equal, it shows that the sphere is in equilibrium. For the line charge model, we model it slightly differently. So instead of a point charge, each tape is represented by each piece of charge, which is known as a line charge. So we have to iterate through each line charge and calculate the force acting on each one. And as it can be seen in the model, the force acting on each line charge is slightly different, as the arrows are not all pointing straight up. So we find the charge on the tape to be 4.16 times 10 to the negative 8 because through trial and error with this charge, we get the magnitude of the electrical force and the gravitational force to be equal to each other, so we know that the tape would be in equilibrium. So there are differences between the models due to assumptions. So each tape had the same net charge is an assumption that was made, and this is because the tapes were prepared in the same way, so we can assume that the tapes have the same net charge. In the first model, we also assumed that the tapes were treated as point charges, where all the charge of the tape is concentrated into one point, which of course is not actually how it is in real life. So for the what if questions, this asks if electrons were positively charged and protons were negatively charged, how would it affect the interaction of the tape with other charged objects? So since the tape had an excess of electrons, it was negatively charged. So in this scenario, it would become positively charged. The tape would still repel positive charges and attract negative charges. Something that would stay the same is that if the tape was brought near a neutral object, it would still be attracted to it because it's still a charged object, even though now it's positive as opposed to being negative. Now, this question asks to compare the data from the point charge model to the line charge model. So I said that the values are different because the point charge is an oversimplification. The line charge model is more accurate because the charges on the tape are more likely to be spread out, like in a line charge, rather than concentrated into one point.